In this video lecture, we're going to cover section 3.1, which covers quadratic functions. And we're going to start with our vertex form of a quadratic function, which is really a parabola. Okay, and so it says the quadratic function f of x equals a times x squared plus b times x plus c can be written as y equals f of x, which in other words y equals and f of x equals is the same thing. And we're going to start with the vertex form, which if you will fill this in on your notes as I fill it in here, is a times x minus h squared plus k. And this is called the vertex form for a quadratic function, okay, where a cannot equal 0 and hk is the vertex of the parabola. Notice that when we have hk, when you pull this h out, you do opposite sign for it, but you leave k the way that it is for the vertex, okay? So h is our x value of our vertex, k is our y value of our vertex of this parabola. Okay, and so if you look down here, this is from your textbook, page 285. You have two ways that a parabola can open. It can open down or it can open up, and we have what's called the axis of symmetry, meaning that, like, think about butterfly wings. If you were to fold them up, they match up exactly on each side. Same thing with this parabola here. If I folded it along this line here, this axis of symmetry, it would match up exactly the same on both sides. Same thing for the one that opens up, and that's called our axis of symmetry, and it always runs right through our vertex. It's the vertical line that runs through our vertex. And so we're going to talk more in a minute about how to find that when we look at actual examples, okay? Another thing I want to point out here is that if A is positive, then your parabola is going to open up. If A is negative, then your parabola is going to open down. We've already talked about the vertex would be HK, okay? So now we're going to do example 1 in vertex form on the next page. Okay, and so we're going to start here, and it says graphing quadratic functions that are in vertex form. Graph each quadratic function and give the required information for each parabola. So we're going to answer all of the information that we have requested here for this given quadratic function. Okay, so we start with, on example A here, f of x, which again, remember, is the same thing as y equals x plus 2 squared plus 1. I know, first of all, that this opens up because there's understood to be a positive 1 in front of this parentheses. This is in vertex form that we just talked about. And so I know that the first answer here, direction of opening, this parabola should open up. Okay, so now the next thing we want to do is give the vertex for this parabola. So remember, HK is our vertex, and when we pull this H out, we have to do opposite sign here. So that will be negative 2 for H, positive 1 for K. So our vertex here is negative 2, positive 1. Okay? Next thing it wants us to do is answer the axis of symmetry. And I always like to stop here and graph mine on my graphing calculator to kind of get a visual first before I go any further. So let's go ahead and do that on our graphing calculator. Okay, so if we take our graphing calculator and we go to y equals, we're going to type in exactly the way it was written on your paper. So we're going to do parentheses x plus 2, close parentheses, squared, plus 1, enter, and graph. Okay, I can see that this parabola opens up. We've already answered that. We said the vertex should be at negative 2, 1, which would be 2 to the left and up 1. That looks good. And now it wants the axis of symmetry. And so if we look at, again, thinking back to what we said on the previous page, that axis of symmetry is the vertical line that always runs through the vertex. And so the equation for our axis of symmetry, since it's a vertical line, is always going to be x equals, and it's whatever h is. In other words, whatever x value we have in our vertex, the axis of symmetry is going to be x equals that number. So x equals negative 2 is our axis of symmetry. Okay, so then it wants to know about x-intercepts. So let's go back and look at this graph for just a second. I see that this graph opens up and the vertex is above my x-axis. We can see from this graph on our calculator that this parabola is never going to cross the x-axis. Therefore, it has no x-intercepts. So for x-intercepts, notice it says here, if any, I'm going to put none. Okay, y-intercept. Again, I can see from the graph that it definitely has a y-intercept. That's the point where the graph crosses the y-axis. And to find that, to find our y-intercept, remember how we do that? We let x equal 0 and solve. Okay? And so that means we're going to have this ordered pair where x is 0. And so now I'm going to plug 0 back into my equation for x. Remember, f of x equals is the same thing as y equals. And I'm going to have y equals, and I'm going to do 0 for x plus 2 squared plus 1. And so y equals, well, 0 plus 2 is 2. So I have 2 squared plus 1, 4 plus 1, y equals 5. So 0, 5 is my y-intercept. Okay, let's go ahead and look, and let's go ahead and sketch the graph over here on our graph now. And so I know the vertex is negative 2, 1. And so let's start there. That would be 2 to the left and up 1. We know that it opens up. I also know that my y-intercept is 0, 5, so I can plot that. And then I can get another point, or several points, however many I would like to get, but we don't really have to have but about one more to finish our sketch, is to do second graph. Second graph pulls up this table of values. So maybe you can see it better if I move the paper. Okay? And on this table of values, I see that, again, we have the vertex that we had listed, which, if we go back up, was negative 2, 1. The y-intercept was 0, 5. There it is. And if I want another point, let's try negative 4, 5. Okay, I'm just picking that from my table of values. So that would be 4 to the left and up 5. And so if I draw that, or draw my graph through those points that I've plotted, I have a sketch of that parabola that opens up. Okay, so now let's talk about domain. Remember, domain are your x values. And think about from left to right, that your x-axis, what's going on with this graph. Well, this graph, if we could kind of zoom way out and see the bigger picture, so to speak, we would see that it continues to go to the left forever and ever, and it continues to go to the right forever and ever. So in other words, thinking about your x-axis here, that would be from negative infinity to positive infinity. And for every parabola that we cover in this particular course, in college algebra, your domain is going to be negative infinity to positive infinity. And that's for this course. You can remember that, okay? So let's move on to the range. The range would be our y values, okay? think about your y values lowest to highest, and look back at your y value in your vertex. If your parabola opens up, your range is going to be your k value from your vertex, in other words, your y value from your vertex, which in this case was 1, to positive infinity. So again, if your parabola opens up, your range will be whatever your k value is in your vertex, which in this case, my y value, my k value of my vertex was 1, to positive infinity. Okay? So we have now answered all of the necessary information for example A. Okay, let's keep going to the next page. The next example still will be in vertex form. Okay, so let's start with the first blank. Direction of opening. Again, I see here A is negative this time, so this parabola should open downward. So we're going to put down there. Okay? The vertex. Again, since this is in vertex form, I can very easily pick out the vertex. Remember to take the opposite of this. So H would be negative 3, and K would be 4. So my vertex should be negative 3, 4. And remember, if you go ahead and graph it on your graphing calculator, so go back to that y equals, and you want to clear the other one that we just did out. And now let's type in exactly what we have on our sheet here, okay? And so we have on our sheet here, negative, use your negative key for that, 4, parentheses, x plus 3, close it, squared, plus 4. Enter and graph. Okay, and so our axis of symmetry, remember, is this vertical line that runs through the vertex. And so our axis of symmetry, the equation is going to be x equals, and whatever our x value is in our vertex. So x equals negative 3 is our axis of symmetry. Okay? Our x-intercepts, again, you can see from the calculator that you do have x-intercepts. I see 2 places that is crossing the x-axis, so it definitely has 2 intercepts. And to find the x-intercepts, okay, and you remember that from a previous section in this course, but to refresh our memory, to find x-intercepts, we let y equal 0 and solve. So in other words, we're going to wind up with 2 ordered pairs that look like this, where y value is 0. And I know it's 2 because remember, looking back at this graph, there are 2 places this crosses the x-axis, as you can see there. Okay, well, remember, f of x is the same thing as y equals. So if I put a 0 in here for y, f of x is the same thing as y equals. So 0 equals negative 4 times x plus 3 squared plus 4. I need to get this equation, though, in order to solve this, I need to get it in standard form. Remember, this is vertex form, okay? And so I'm going to take it to what's called standard form. And so I'm going to square this binomial first, so I still have negative 4 here in front. And to square this, you can either pull it out and say x plus 3 times x plus 3, or you really should know how to square a binomial. So that would be x squared plus 6x plus 9 plus 4. And then I'm going to distribute this negative 4 times all 3 of these terms. So that would give me negative 4x squared. Negative 4 times 6x would be minus 24x. Negative 4 times 9 would be minus 36 plus this 4 on the end. Combine these two like terms. 0 equals negative 4x squared minus 24x minus 32. Now, what good did that do me? Well, now that I have it in standard form, and if we wanted to get really technical, we could multiply both sides through by negative 1 so that our a here wasn't negative. But I'm going to leave it because I can use, and if you have this program on your calculator, you are welcome to use it as well. I'm going to use my Quad 4 program. And remember, that's our quadratic formula program. So if you don't have quad 4 on the calculator, then you would have to do quadratic formula by hand and use your quadratic formula pencil and paper. But I'm going to use quad 4 on my calculator. So to do that, remember, I go to Programs, move this paper so it'll be a little easier to see, and I find my quad 4 program, enter, and enter again, and it's waiting for me to put in A, B, and C. So let's go back to our equation. We have it here. So A would be -4, B would be -24, and C would be -32. And so that's what I'm going to type into my calculator. So again, I'm going to go back to this. It's waiting for A, and I'm going to do A is -4. Be sure to use your negative key, not your minus key here. B is -24, and C is -32. Enter. And so I hit enter again, and I see that it says real roots. That means that it did have X-intercepts, okay? And we knew that from looking at the graph. But it tells me that X equals -2, X equals -4. So if I write that on my paper, X equals -2, X equals -4, that means my ordered pairs would be -20 and -40 for my X-intercepts. So let's fill in the blank with that, okay? So -20, -40 are my X-intercepts. I'm going to go ahead now and graph it because I have plenty of information to graph it. So I'm going to do my vertex first. We know it opens down, remember that. So -3, 4. So that would be 3 to the left and up 4. -2, 0, 2 to the left, stay there. -4, 4 to the left and stay there. And that's certainly enough to give us a good sketch here on our paper of that parabola. Okay, but we still have to answer the Y-intercept, okay? And so the Y-intercept, and I'm going to get another sheet of paper here so I have plenty of room. So the Y-intercept, to find it, remember this from another lesson, you let X equals 0 and solve. Okay, so going back to our original equation here, f of x is the same thing as y equals, and so y equals, and I'm going to do -4, parentheses, and I'm going to do 0 for x, 0 plus 3 squared plus 4. So y equals, well, 0 plus 3 is 3, so I have -4 times 3 squared plus 4. Follow your order of operations. And so 3 squared is 9, so that's -4 times 9 plus 4, following order of operations. Y equals -4 times 9 is -36 plus 4. Y equals -32. So, and again, we let x equal 0, so that means our ordered pair would be 0, -32 for our Y-intercept, okay? So I'm going to put that in my blank. 0, -32 would be my Y-intercept. Now, of course, you can't see that here on just this little piece of the coordinate plane that we're given here to graph on, but your Y-intercept would be 0, -32. Okay, remember from the previous problem, the domain of these left to right x values would still be -infinity to +infinity. Okay. And our range, we're talking about our y values lowest to highest when we're talking about the range. And so this time, because it opens down, when your parabola opens down, your range is going to start with -infinity, comma, and it's going to go to whatever your k value is in your vertex, or in other words, whatever your y value is in your vertex. So -infinity 4, and we put a bracket around 4 because it's included. I did not mention that on A, but always put a bracket around the part that's the actual y value, okay, of your range, okay? So -infinity to 4 with a bracket around 4, okay? So that will finish up part A of section 3.1. The next thing that we're going to look at on the other two examples for this section will be graphing when the quadratic function is given to us in standard form instead of vertex form.